Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Step on inside and we are going to be reviewing some things that we've been doing out of Chapter 3 when it comes to graphing, vertex form, standard form, and factored form, otherwise known as intercept form of quadratic equations. And there are some word problems, I believe, along the way of this little packet that I have. It's brought to me by another teacher, a colleague of mine, so it's not my worksheet of sorts. I did provide it for my students, however, and I'll provide it for you guys in the description section down below in the PDF. So you can download it for yourself and print it out for yourself or do whatever, just follow along as you so please. I'll also provide timestamps for each individual problem. Now I plan on going over these rather quickly in a way that as much as my students are supposed to understand the material is how I'm going to do it, not so much of a reteach, if that's cool. Also along that same gesture, you know, the colleague who's providing it for me, maybe she teaches something differently. I know that she teaches graphing differently and that she uses tables and stuff. So I don't use tables and I'm not planning on using them. So if you're going to follow along with the graph stuff, maybe you just try and graph it on your own and see how things match up if you graph differently than I do. Without further ado, guys, I'm going to go ahead and get started right now. Let's go and take a look what we got going on. Number one, graph the following function, or we'll graph the following function. Here on number one, we have f of x equals x minus 2 quantity squared plus 4. So this vertex, and I'll just label it right here because they're asking, the vertex at hk is at 2, 4. So I'm going to go ahead and plot that over 2 up 4. And my stretch factor is 1. It's a positive 1. So from here I can go over 1 up 1, over 2 up 4. 1, 2, 3, 4, like so. Now, I also have an axis of symmetry, and this is something that they ask about, so I'm going to go ahead and get that provided for you as well. Here's the axis of symmetry. It is at the line x equals 2. Let's thin that out a little bit. All right, this is going to be at the line x equals 2. And this graph opens upward, by the way. Now, with this axis of symmetry, I can reflect these points across right here and right there. Now, from the graph alone, I can also answer a couple of other questions. It looks like they ask about y-intercept. I don't see anything about x-intercepts, which is good. This doesn't cross the x-axis, so I couldn't give you any x-intercepts even if I wanted to. Y-intercept, I can tell by the graph that it's crossing the y-axis at, I think that's 8. 1, 2, 3, 4, 5. 0, 8. So the y-intercept is the point 0, 8. There's another way you can get the y-intercept if you wanted to. I could set x equal to 0 in this equation. The y-intercept is the value of y when x equals 0. So it's 0 minus 2 squared plus 4, or negative 2 squared plus 4, which is 8. So you would get 0 for x, 8 for y. Remember, it's the value of y when x equals 0. That's the important way of saying that. This has a minimum because it is upward facing, and so it bottoms out here, and that can help answer parts on the range as well. The domain is all real numbers, as these graphs would be. They go left and right forever. The range is, the lowest point is 4, and it goes upward from that. Y is greater than or equal to 4, and that's number 1. Number 2, we have another vertex form written equation, only with a negative 1/3 out in front this time. So let's try and do some of the same things as before. Because this is negative, guys, this graph is going to open downward, and we'll see that when we draw the graph itself. The vertex at hk is 6, negative 2. And with that in mind, the axis of symmetry is at the x equals h equation, so x equals 6. So immediately, I know that I'm going to have the following things happen. That and this, at least close as I can make it. And then when I plot these points here, if I go over 1, I go down 1/3 of 1 and reflect across. If I go over 2, I go down 1/3 of 4, which is 4/3. That's 1 1/3. If I go over 3, I go down 1/3 of 9, which is 3. And if I go down, over 4, I go down 1/3 of 16, which is 16/3, 5 1/3. 3, 4, 5 1/3, like that. So those are some points that I could plot and get. And there's that downward facing graph as it does open downward. And reflecting across the axis of symmetry, we get those features. Now, I did not go far enough to figure out what my y-intercept would be. If I went 5 away, I'd go down 25/3, which is 8 1/3. If I go 6 away, I'd go down 1/3 of 36, which is 12. If I went 12 away from negative 2, right, from negative 2, it's 12 down, I'd be at negative 14. So I already know besides the maximum. I already know my y-intercept is going to be at 0, negative 14. Now, how did I get that? Well, it's based on my graph procedure. But I can also go ahead and substitute 0 in for x and do the same thing as I was... Well, you won't be able to see that. Let's see. Let's draw the arrow a little higher up. F of 0 is negative 1/3. 0 minus 6. Quantity squared minus 2, which is negative 1/3 of negative 6 squared minus 2, which is, and I'm going to write this out, this is negative 1/3 of 36 minus 2. Negative 12 minus 2 is negative 14. And that's what I did, right? I said over 6, go down 1/3 of 36. So go down 12 from negative 2. So it seems to line up. Domain is all real numbers. The range is y is less than or equal to negative 2. The negative 2 is the highest point. We go down from there. And that is B. That's the first page. Flip to the second page. We're going to do some of the same stuff. We're going to graph these things, answer the questions, but these are not in vertex form anymore. They are in standard form. Does this function open up or down? With this a value being negative, this thing will open downward. I don't know the vertex just yet. In order to get this vertex... Well, here, let's answer this first. This is in standard form. Y equals ax squared plus bx plus c. A is negative 1, b is 4, c is negative 2. The c value gives you your y-intercept. When x is 0, y is negative 2. So I already know that not only this is a point, that's the y-intercept, it's also a point on the graph. It's not the vertex, but or it could be. Well, it's not. Anyway, so to find the vertex, we have to get the axis of symmetry. X value is going to be at negative b over 2a. When you are in standard form, you can find the x value of the vertex this way. Negative 4 over negative 2 is positive 2. So x equals 2 is the axis of symmetry and the value of x for your vertex. So to find the y value of the vertex, we have to substitute 2 into the equation. So negative 2 squared plus 4 times 2 minus 2, which is negative 2 plus, negative 4. Negative 4 plus 8 minus 2, which is 2. So you get 2 for x, you get 2 for y. Here is the vertex on the graph, and here's the axis of symmetry that goes along with it. You could have drawn the axis of symmetry first. Now, there is a point that reflects across and corresponds like that, which is cool, but I'm going to plot the rest of the points as well. With a being negative 1, I can go 1, 1, 2, 4, just like that, over 3 down 9, and reflect that, and those are the points I can fit for this graph. So the vertex is still very important to get. Negative b over 2a is the way that we're going to do it out of standard form. This graph was not factorable, by the way, and if it was factorable, it would have hit very nice x-intercepts. In this case, it does not. The domain is all, this has a maximum. The domain is all real numbers, and the range is y is less than or equal to 2. Letter D, 2x squared, k of x equals 2x squared minus 12x plus 19. Same kinds of questions are going to be asked. Let me move my face. Let's check it out. Does this graph open up or down? It opens upward. This time it'll open upward because a is positive. It is a positive 2. The axis of symmetry comes from the x value of the vertex. We are going to get x equals negative b over 2a, which is 12 over 4, which is 3. X equals 3 is the axis of symmetry, and this time I'll actually draw that line first. And listen, the y-intercept is not plottable if I'm scaling by ones. For all intents and purposes, guys, I'm just going to go ahead and scale by ones. I don't know. Do you want me to scale by 2? Okay, let's scale by 2s. Let's scale by 2s on y, like this. I am going to scale by 1s on x, however, like I already began. Okay, hope that's cool. Let's do it. Okay, so now I can plot the y-intercept, which is at 0, 19. So that's going to be halfway. These go by 2, so 12, 14, 16, 18, 20. 19 is halfway between these guys. Now the vertex, I'm sorry, I stopped at the x stuff here. What I was going to say is if I plot the y-intercept, I could reflect this point across just like so. Keep in mind how the scaling is going. If you want to change your scale, go ahead. But if you follow mine, understand what I'm doing. Going by 2s on y, going by 1s on x. By the way, I can also put a negative 10 here and a positive 10 here. Okay, the vertex, so x equals 3. Let's substitute 3 in for x to find the y value. K of 3 is going to be 2 times 3 squared minus 12 times 3 plus 19. 3 squared is 9 times 2 is 18. We're going to do minus 36 here and plus 19. Negative 18 plus 19 is 1. So the vertex is at 3, 1. Now keep in mind, 1 is halfway between 0 and 2, just like that. And every other point I can plot from here is if I go over 1, I'm going to go up 2. That's 2 times 1. And keep in mind, this is though we're scaled by 2's when we go up. Over 2, up 8, 4 times 2, so 2, 4, 6, 8. It's kind of the same way of going 1, 1, 2, 4, things like that, just because my scale. Over 3, I would have gone up 18, 9 times 2. 18 up from 1 is 19, just like that guy right there, so that's fine. That's all plotted, right? So keep in mind I'm by that scale. I don't know if I'm going to do that again. I might keep it normal just to see the stretches for how they are, but I wanted to focus on the y-intercept as long as that was a featured point based on the equation. There are probably other questions down here. Domain is all real numbers, and the range is y is greater than or equal to 1. 1 is the lowest point there. That was it on this page, so that was all we had to do for the graphing. Let's move forward. Oh, more graphing. So these are factored form, also known as intercept form. Okay, they are both named that for either reason. They are factored, and factoring gives us the intercepts. The reason why we get in specifically x-intercepts. Do they ask for them here? They do not. So let me point out this right now. As far as x-intercepts go, this is all about setting y equal to 0. If 4 times x plus 2 times x plus 1 equals 0, we want to find the values of x, negative 2 and negative 1, that would get us 0 for y. We have x-intercepts of negative 2, 0, and negative 1, 0. Just like y-intercepts are values of y when x equals 0, x-intercepts are values of x when y equals 0. Set y equal to 0, solve for x. The reason why factored form is so great for this is we can use the zero product property. If x plus 2 equals 0, then x is negative 2. If x plus 1 equals, if these multiply to equal 0, then I'm teaching when I said I wouldn't. If these multiply to equal 0, then either 4 equals 0, which is impossible, or x plus 2 equals 0, in which case x is negative 2, or x plus 1 equals 0, in which case x is negative 1. This allows me to get these guys right here, and the axis of symmetry is always exactly halfway in between these. So as far as getting axis of symmetry, well, if I have the visual, I can say what's halfway between negative 2 and negative 1. That's negative 1.5, negative 1.5. In order to do that mathematically, we would average your two x-intercept values. You get negative 2 minus 1 is negative 3, and negative 3 over 2 is negative 1.5. So the axis of symmetry is x equals negative 1.5, exactly halfway in between these two guys. Now, we always want the axis of symmetry, not just because they asked for it, but because it helps us get our vertex. So, how do we get the vertex from that? We now substitute negative 1.5 in for x to get the y value. So, over here, the m of negative 1.5, we're going to do 4 times negative 1.5 plus 2 times negative 1.5 plus 1. Which is 4 times 0.5 times negative 0.5. This is half of 4, which is 2, half of 2, which is 1. Make it negative, you get negative 1. So negative 1.5 comma negative 1, it's right there. Now the vertical stretch factor is 4. I can find some other points by going over 1 up 4 times 1, which is 4. Over 2 up... Oh, where's 2? Over 2 up 4 times 4, which is 16, which I cannot fit. So that's as much as I can plot, but I want to find the y-intercept as well, because they're going to ask us for it. Down here, we do have a minimum, by the way. This graph does open up. The y-intercept, we have to substitute 0 for x, so let's find that out. M of 0. And that's going to be, that's going to be equal to 4 times 0 plus 2 times 0 plus 1, which is 8. So I can plot this point as well, and that guy. Now, I never got this in standard form, but if I did, 8 would have been the constant value. And I don't have to use negative b over 2a anymore because I found the axis of symmetry by averaging my two vertex values, or finding half the distance between them on the graph, which was negative 1.5. Generally, we don't see a lot of ones that are halfway in between like that, but it's possible to have, and that is among one of the times. Did we answer well? No. Y-intercept was 0, 8. Domain is all real numbers. Range is y is greater than or equal to negative 1. Negative 1 was the lowest value on y. Let's move forward and let's look at part F. I believe this is probably the last version of these kinds of questions. N of x equals. Now the negative is in reference to the a value, which is negative 1. This graph will open downward. This is x minus 3 that appears twice. The 1x intercept that exists is positive 3. So positive 3 comma 0, we have this. Now you're probably curious about the axis of symmetry talk. Well, this is what's called a repeated root. See, we don't play with this often. This is what's called a repeated root, where the axis of symmetry, look, if you want to say x-intercept is 3 and 3, because it was the same thing twice, then you average those two things. 3 plus 3 over 2 is 6 over 2, which is 3. Your axis of symmetry, guys, is on the vertex. The vertex being on the x-axis. Excuse me, your vertex is on the x-axis. The axis of symmetry is crossing through the point on the x-axis. That's what I wanted to say. It's at x equals 3. It's a little different. It's a little interesting. And maybe you'd have to find more points to determine that. Maybe use negative b over 2a after expanding it. But the bottom line is it's quadratic because you have two things that are factored. So it will be U-shaped because it only hits the x-axis once. That's because the vertex is on it. Now, the vertex is indeed 3 comma 0. This has a maximum because it opens up downward. They're going to ask about the y-intercept down below. So n of 0, we're going to be doing negative 0 minus 3 times 0 minus 3. Negative 3 times negative 3 is 9. Opposite of that is negative 9. So the y-intercept is at 0 comma negative 9, like that. And there's a corresponding point 3 units away, just like that. I could have also found this by graphing it first. The a value is negative 1. It's flipped over, and we go over 1, down 1, over 2, down 4, over 3, down 9. Hey, look at that. We still hit that same point. So this thing goes just like that. Good old giraffe. Okay. Domain is all real numbers. Range is y is less than or equal to 0. All right, let's move forward now to not graphing, unless they do. It says rewrite in vertex form. So rewrite the following in vertex form. We have y equals 2x squared minus 16x plus 31. In order to write it into vertex form, we have to come up with a, h, and k. Because vertex form takes on the form y equals a times x minus h quantity squared plus k. To find the vertex when you're in standard form, there's this method called completing the square. I believe that our group, I know our group hasn't hit that just yet. That'll happen in our chapter 4. So if there's that method, we're not going to do that. We're just going to find the vertex using negative b over 2a and plugging that value in. Now, the a value is 2. It's the same a value that I see right here. The h and k, on the other hand, let's figure those out. It's based on that vertex stuff. The axis of symmetry, it's at negative b over 2a, which is 16 over 4, which is 4. That also represents the h value. So h is 4. K is based on substituting 4 into here. So f of 4 is going to be 2 times 4 squared minus 16 times 4 plus 31. I'm going to just be quick with this. 16 doubled is 32, minus 64 is negative 32, plus 31 is negative 1. So the k value is negative 1. So we have our a, h, and k for the vertex. We'll write it in this form here. This is going to now say f of x equals a times x minus h quantity squared plus k is minus 1. There's your vertex form version of this. We'll do the same thing on this one. B, we're getting in vertex form, only it's beginning in intercept form, which for us means we can find the vertex by other means. You could expand it to standard form. That's not really the goal I want to play with right now. I want to determine these x-intercepts first, just like we did on the previous graphs above. This is going to be at x equals 1 and at x equals 4. Those are the values that when we plug them in, we get 0 for y. So half the distance between these is where the axis of symmetry appears, the vertex x value, if you will, or h, if you will. So 1 plus 4 divided by 2. Average your two values, or half the distance between, either or. Because I don't have a graph, I don't really want to talk about half the distance. 5 over 2 is 2.5. So your h value, let's write out this AHK stuff. AHK nonsense. A, by the way, is -2, guys. It's that vertical stretch factor there. My h value is 2.5. 2.5. Now I'm going to substitute 2.5 into my g of x equation to find the k value, the y value for the vertex. 2.5 minus 1 is 1.5. 2.5 minus 4 is -1.5. If you had previous videos with me, you know this repeated pattern of 1 positive, 1 negative, the opposites of, as this works out. 1.5 times -1.5, wow, is -2.25 times -2 is +4.5, if I did that correctly. I did. So that's going to be the k value there, and thank goodness I'm not graphing this, but I am writing out its equation. Vertex form, g of x is a times x minus h, 2.5, quantity squared plus k. You can write these as fractions as well. You normally see me do things as fractions, actually, but for the sake of, I'm sorry, that should say 4.5. I don't know what I was doing. Mr. Robinson, you're making a mistake. I don't know what I was saying. Oh, I generally write things as fractions to be precise, exact, but whenever I'm dividing something by 2, I'm going to stay precise. And because sometimes we plot them on graphs, I might want to state that how it is. All right, rewrite this in standard form. This is just all about expanding this, guys. We begin with this part right here, x plus 3 quantity squared. So x plus any a plus b quantity squared is a squared plus 2ab. We're going to double x times 3, which is 6x, plus b squared. 3 squared is 9. Now I distribute the 3. You can't distribute the 3 beforehand because order of operations, exponents go before multiplication. So now we're going to distribute this here, 3x squared plus 18x plus 27. And 27 plus 2 is 29. So we will get 3x squared plus 18x plus 29. Part B, g of x equals, this is in factored form. I'm going to kind of apply the same principles as I did before. I don't want to distribute this -2, not that you're not allowed to. It's just that people will distribute it to everything. That you're not allowed to do that. You can only do it to one thing at a time like this. But I prefer just foiling something out. I think that I'm a lot faster working this out and then multiplying the -2. Plus, that's how we factor in that opposite order. We factor the -2 out first as GCF, and then we factor that part into this. So I think it's worth it to go this way. And it will apply the same way like this. -2 times, I'm going to get x squared minus 6x plus 5 when I do the whole foiling method. -5x minus 1x is -6x. -1 times -5 is +5. And distribute the -2 into here. -2x squared plus 12x minus 10. Now, I am going relatively faster than I do in other videos, partly because, like I said, it's something that's probably you're supposed to know at this point. But really, you're supposed to know because this is from a previous chapter. The expansion, the foiling, the multiplication, this is from chapter 2. Graphing is chapter 3. What we do with it, calling it standard form and doing stuff like that is different. Number 4, write the equations of the given function in intercept form. In order to do this, you want to identify, they said intercept form, which is also factored form. So this is going to be our a times x minus p times x minus q. Our goal is to come up with the p and q, which are our x-intercepts, which are these two guys right here. So it doesn't matter which one's which as far as p and q goes. So our equation right now will look like y equals a times x minus 3 times x minus 7. Those two intercepts there. What's important now is to find out what this a value is. What stretch factor makes us go from whatever vertex we're at, which, by the way, these are scaled by 2s. I don't know if you noticed. So I don't even know if that's at like 5.1 or 1.5, right? I don't know. But what makes it go from this vertex and hit these points and then hit this point down here, stuff like that. So this is an xy value that exists as a solution to our equation. We can substitute 1 for x and -4 for y and solve for the a that would make this thing so. Right? That's the goal. That's what we're trying to figure out. So -4 equals a times -2 times -6. Okay, -4 equals 12a. Divide both sides by 12, and you're going to, as a reduced fraction, this is where I am going to write a fraction, a is -1/3. So our final equation will be y equals negative 1/3 times x minus 3 times x minus 7. You restore the x and y variables because we have to represent the entire graph, not just that single point. The single point was meant for us to then be able to find the a value based on this stuff, and that is our a. I knew it was going to be negative because it went upside down. I assumed it was going to be compressed based on its appearance, and it seems that it is very much so. Okay, this next one also has the same kind of weird hiccup when it comes to vertex bits, so I couldn't apply my own stretch factor nonsense I'd like to do. But this time they don't tell us the numbers outright. You have to identify them. So I have a p and q of 1 and 4, and I have a y-intercept, or another point, of 0, 4, which will be my xy for this next problem. And I'm going to go and move myself again. And let's see what I can fit. So this begins as y equals some a times x minus 1 times x minus 4. Let's, and by the way, they mentioned intercept form, right? They didn't say do standard form, vertex form, anything like that. So leaving in this form is just great. I'm going to substitute 0 for x and 4 for y. So this will be 4 equals a times 0 minus 1 times 0 minus 4. Hey, check this out. 4 times a, so a is 1. I honestly didn't know that. I had no idea. So this is going to be the equation y equals. You know, if a is 1, I don't need to write it because 1 times anything is just that thing. So x minus 1 times x minus 4. And that is our equation. There we have it. All right, let's move forward to writing equations in vertex form. So this time we're going to apply it, write it in this form. Y equals a times x minus h quantity squared plus k, which means we need the vertex. We need the stretch factor. So the vertex is going to be this guy here. This is at 2, -3. That's our h and k. So for all intents and purposes, your equation looks like y equals a times x minus 2, quantity squared minus 3. Your goal is to solve for a. We can do the same thing as we did before. You got to pick a point. So this point sounds good. That's 1, -5. Now, the way that I would do it, personally, as I talk to my students, is I'd say, hey, normally, guys, we'd go 1, 1, 2, 4, 3, 9, things like that. Because we go down, we know it's negative. And instead of going 1, 1, we're going 1, 2. You took that 1 and you doubled it. I already know my a value is going to be -2. I'm going to write the answer before we get it just to say that, hey, we can do things based off a table list or calculating list graphing method if you have it. But let's go ahead and get it going by 1 for x, -5 for y. Let's substitute. We got -5 equals, let's solve for this a times 1 minus 2 quantity squared minus 3. I'm going to do two things at once if it's cool. I'm going to add 3 to both sides right here. And I'm also going to do 1 minus 2. So -5 plus 3 is -2. And 1 minus 2 is -1. And we're squaring that. -1 squared is 1. So we do get a equals -2, right? 1a is -2. So a is indeed -2. And that gets us that equation. Confirmed. Part B. Another vertex. This vertex looks to be at -4, 3. So that's your h and k. So we know our equation is going to look like some y equals a times x minus h. Remember, we write a plus here. Quantity squared plus 3. How many people misread, forget to write the quantity squared? A lot. Try and not be that one. We got to find a point this crosses through. Now, they picked this point out here, which is totally fine. It looks like it also hits there. You could pick what you want, but if they give you one, why not? So this is at 0, 7. Now, for me, I'm in the form of we're going over 4, and we're going up 4. Generally, we go over 4, we'd go up 16, because that's 4 squared, right? So, we would go up 16, but now we're multiplying it by some a, and now we're only going up 4. Divide by 16, we're going to get 1/4. So I know that that's going to be the a value. We're going up 1/4 of what we normally would. But hey, let's substitute this for x, this for y. Let's go. 7 equals a times 0 plus 4 quantity squared plus 3. Subtract 3 from both sides. I'm going to get 4 equals, and 4 squared is 16. 16a. Hey, look, it's the same equation as before, for good reason, because the math still agrees. A is going to be 1/4. So the equation is y equals 1/4 times x plus 4 quantity squared plus 3. I don't know how many pages I've done so far and how many are left. I know there are word problems by the end of this thing. Okay, that's here. So I think we only have 2 more pages to go. So I'm actually at a pretty good pace here. Jason, so I've done this problem with my students before, and I think I have an old video. If I've done it with them, I have an old video that has asked these questions. Didn't ask initial height, though. It asked a different question at the time. Jason jumped off a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by the function here, where t is the time in seconds and h is the height in feet. I'm not going to get deep into the nitty-gritty. I'll tell you this much. I've done this question in the past. There's a video that I'll also link down below for more quadratic word problems, because I haven't done this one before. So, but I've covered it before, and I'll tell you what all this stuff means and what we're talking about. I'll get to some bits of it just to talk about it right now, which is basically, it's a negative quadratic, which means we have a parabola that's going upside down. They're going to ask for when he reaches maximum height. We're talking about the vertex. How long did it take for him to reach his maximum height? This is time, this is height. T is your new x, h is your new y. So, we want to figure out, what's the t value of the vertex? So for the vertex, t is negative b over 2a. We're going to do negative b, 16, over 2a, negative 16. So negative 16 over negative 32, which is positive 0.5. Now, it is a word problem. Time is in seconds. I'm going to say it took 0.5 seconds. Half a second for Jason to reach his maximum height. What was the highest point he reached? This is the y value of the vertex. We're finding out h. We're going to do h of 0.5. So negative 16 times 0.5 squared plus 16 times 0.5 plus 480. It's negative 4 plus 8, which is 4, plus 480, which is 484. And that's 484 feet. So that's the highest he gets. Now, he didn't jump up 484 feet in the air. He was at some other point. What was his initial height? That's the question. This is at time 0. What is h of 0? Well, good news is we're in standard form. That means this term wipes out, this term wipes out. You're left with 480. It's the y-intercept. This thing, he starts at 480 feet. 0, 480, which is the answer, by the way. 480 feet. And once again, the vertex was all about 0.5, 484. Half a second later, he was 484 feet in the air. I know my word problem asked at what time did he hit the water, which we solve by factoring this thing. And we find out what the x-intercept, or the t-intercept in this case is right there. I think, I can't remember. Might have been 6 seconds. I can't remember. The following equation represents the path of a donut hole being thrown by Mr. London. Don't know what that is. Where x represents the time in seconds the donut is in the air, and y represents the height in feet of the donut. What I don't like about this problem is gravity isn't mimicked anymore. That negative 16 is there for a very specific reason. Now it's not here anymore, but that's okay. So x is now the time, y is now the height of the donut. All right, so this is the path. Graph the equation, show the path of the donut hole, show at least 3 points. I'll show you as many as I can fit, guys, integer-wise. So this, is that the first equation that we had? That's the first equation that we had. What? I just went, that's the exact same equation. Okay, well, let's just do it again. The vertex x value is negative b over 2a. Which is 2. That's the axis of symmetry. The y value is by substituting 2 into here. Negative 4 plus 8 is 4 minus 2 is 2. So your vertex is at 2, 2. Which is the maximum height of the donut, I suppose. The stretch factor is negative 1. So I'm going to go 1, 1, 2, 4, and 3, 9. Hey, I plotted at least 3 points. I plotted 7. And it's the same 7 as what we had last time. Now, is that all they asked for the problem? Oh, you know what I'm also going to mention with this? Oh, let's see. The equation represents the path of the donut hole being thrown. Now, they're asking us to draw this graph, but guys, I'm going to be a little more particular about this and say that, you know, word problems have a different thing when it comes to domain and range and such. And, like, when something happens, I don't know how good this problem is in terms of representing a graph for this word problem and what we want to do. But here's the thing. At time 0, I don't know what's being stated as far as, like, we were negative 2 feet below and things like that, but there was probably no time before the donut was actually thrown, so that probably doesn't count. and if it's thrown at him, maybe it hits it on the ground. So I don't really know. I wanted to erase or dot some lines to say what parts did apply and what parts didn't. The Jason question, basically, like this, is that this time doesn't matter before, and once he hits the water, that time after doesn't matter, and the domain and range is really just represented by those two parts. This question has kind of a more bizarre parabola as a result of it. So I don't know. I'm just going to draw the parabola as it is. I don't even see any questions. Maybe they're on the next page. They are. At what time does the donut reach its maximum height? That was 2 seconds. That was x equals 2. What was the maximum height? That was the y value. That was 2 feet in the air. And they said rewrite in vertex form. Okay, so not many questions were represented here. H was 2, K was 2, the A value was -1, okay? So it's going to be y equals -1 times x minus 2 quantity squared plus 2. Not a great question when it comes to word problem stuff. It's just, at least, not the questions themselves. The model didn't really work for a bunch of reasons, gravity included. Last question. Is that an N? Yes. A small independent motion picture company determines the profit P for producing N DVD copies, that's old, of a recent release is P equals -0.02 N squared plus 3.40 N minus 16. P is the profit in thousands of dollars and N is in thousands of units. How many DVDs should the company produce to maximize the profit? Okay, so once again, this graph is upside down, and you know, it's something where it's less of a stretch. It's doing something. So we're going to try and maximize that thing. DVDs is the number of units sold for doing this. So we're going to do our -b over 2a. And I might have to use a calculator. I don't really know. So N for the vertex, N is -b over 2a, which is -3. I said 3, which is -3.40 divided by -0.04. 25, 75, 83. 83. I don't have, my phone's not even by me. Give me 1 second. 3.4 divided by 0.0. 85. Why did I say 83? Why did I say? Oh, I was doing 5 times 8, not 4 times 10. 85. Sorry about that. 85 is the N value of the vertex. Now, they asked how many DVDs. Is it 85 DVDs? N is in thousands of units. This is thousands of units. 85,000. You can also write with the zeros. But 85,000 DVDs. What will the maximized profit be? What will the maximum profit be? Let's substitute 85. Don't substitute 85,000. N is in thousands. So we're going to be doing, this is where I'm going to have to use a calculator for sure. P of 85. So -0.02 times 85 squared plus 3.40 times 85 minus 16. Let me use I have a calculator on my computer. So 85 squared and then times I think it's divided by -50, but times 0.02, so it's negative. I'll just keep that in mind. Oh, times -1, how about that? Times, shoot. No. No. Sorry, 144. I'm sorry about this. Times, I don't know how to do negatives on this thing. Let me just pause this and compute it. We're almost done with this whole thing. Okay, the value I got is 128.5. Now, when it comes to this is also in thousands of dollars. So this is $128.5 thousand. That sounds really weird to write it out that way. I think I'm going to write $128,500. In which case here I'm going to write 85,000 DVDs. Now, for you guys at home wondering why there might be a profit model for something like this, they're saying, why wouldn't you maximize profit by making more DVDs? Why not just make 1 billion of them and stuff like that? Keep in mind, at some point, people stop buying them. I mean, right now, people literally don't buy DVDs anymore. I buy them. I buy Blu-rays. I buy UHD, things like that. I don't buy DVDs, but some DVDs come in the package thing. But the point is, you know, at some point, you made too many, and there's a cost in making them and distributing them and stuff like that. But there is this equilibrium, right? There's optimized value that we do find where you're going to still make more money as you make some more, but don't make too many, because there's some people just won't buy, or you're just gonna have to knock it off for a sale price or something like that. So that's why it's not just, hey guys, just make more, you'll make more money. There's yet to an extent, and that's why this model is kind of here for that. All right, and I think that's the last question. Let's see. That's it. Hey guys, that ought to do it for this one. This is Mr. Robinson. Thank you so much for watching. Again, everything's provided down below. If you just caught the end of it, check the PDF for everything. Excuse me, the description section. Yeah, for everything, including the PDF and timestamps and all that good jazz. Thanks for watching, guys. Take care. I will see you in the next one.